Now, in a short run cost curve, we have several components of cost generally. The first one is fixed cost. First of all, in a short run cost curve, again, in a short run, what happens that I can only change maximum one production factors of production. If I have two factors of production or two input firm, I can maximum produce one factors of production. So considering we are on a short run production function or in a short run cost of production, we will try to learn about different cost structures. So in a short run cost of production, the first one is fixed cost, or you can write it as total fixed cost or TFC. Total fixed cost is the amount of cost, even if production is 0, the amount of cost I need to spend or I need to incur, that is my total fixed cost. That is, it's generally the rent of a hospital building, even if I don't give any immunization, the amount of immunization or the vaccines I have procured, that is my fixed cost, right? Even if they are not being utilized, or if just only one bulb in a hospital building which is non-functional is on, that is my fixed cost. So the total fixed cost is associated generally with the fixed input which is not varying. So the total fixed cost is associated with the fixed input. Now you remember we are talking about a short run production function or short run costs of a production function where we will have fixed inputs, right? So a total fixed cost curve will look like a straight line parallel to the x axis, where my x axis will show the quantity and y axis will show the cost. That means when I increase my quantity, my cost has remained same. This is the fixed cost because my fixed input is not changing at all. Yes, when I increase my quantity, my cost is remaining same. So this is my total fixed cost, and this is the amount I have spent behind my fixed inputs. Yes, so even if there is no production, the output is 0, I incur this amount of cost, and whenever it is increasing, it's not increasing, the total quantity is increasing, total fixed cost is not increasing. So that is where total fixed cost is a horizontal line parallel to the x axis, of course. So the average fixed cost, AFC is total fixed cost divided by the total production, total output, that is the average fixed cost, and total fixed cost remaining same, constant, but the output being increased. What happens? The numerator remains constant, denominator increases. That means average fixed cost will continuously go down. Therefore, the average fixed cost curve will look like a downward sloping curve. This is my average fixed cost curve, this is my quantity, this is my cost. But it will never touch 0 because total fixed cost is not 0. So the numerator is not 0 and the number of quantity may increase to 1000. So it can tend to 0 but will never eventually be 0 if total fixed cost is not 0 in a short run. Yeah. So This is my average fixed cost and total fixed cost, but there are variable inputs. So my variable inputs, the costs associated to the variable inputs is known as total variable cost. The cost associated to the variable inputs is known as total variable cost. And the total variable cost curve will look like a kind of sigmoid curve, is shaped. This is my total variable cost. Here I have my cost and here I have my quantity. That means when quantity increases, the cost initially rises at a high rate, increases at an increasing rate. So, increases at a decreasing rate. So, it increases first and then the rate decreases, gets flattened and then it again increases. So, the total variable cost is kind of a sigmoid curve, and if you see you get a new bike or a new vehicle, so initially as the the mileage is low, the cost is higher, the total variable cost is high, and then slowly it starts decreasing, but it never falls, it increases with the amount of kilometers you are running, the vehicle is running. So the total variable cost keeps on increasing, but the rate of increment is declining, flattening up, and then after a certain while, when it moved a certain thousands of kilometers, it again goes up because of a high depreciation cost and wear and tear. And the average variable cost can be given as the total variable cost divided by the quantity, total variable cost divided by the output, and it can be shown as a inversely U-shaped curve. This total variable cost can be shown as an inversely U-shaped curve, and this is my quantity, this is my average variable cost, this is my cost. So the total average variable cost will first come down, will hit a rock bottom, minimum, will touch the minimum, and then it again starts increasing, because the total variable cost starts increasing at an increasing rate. So when it flattens, at this period, so total variable cost increases at a decreasing rate, right? Total variable cost increases at a decreasing rate. The curve is being flatter. Yeah. So, and this stretch is shown by this part of the average variable cost, which is decreasing, per unit cost is decreasing, and after a certain while it starts increasing. So at this point it touches the rock bottom, and then it starts increasing, because the total variable cost starts increasing at an increasing rate, it becomes steeper. Eventually the total cost is the summation of total fixed cost plus total variable cost. Similarly, average cost or average total cost, you can write it either AC or ATC, is this is the total cost by Q, is total fixed cost by Q plus total variable cost by Q. So the average total cost is nothing but average fixed cost, a summation of average fixed cost plus average variable cost. And if I plot them, I will get a curve like this. My average total cost curve, and this is my average variable cost curve, and this difference is nothing but so if this is my average variable cost, this is my average variable cost, and this is my average total cost, then this difference is nothing but the average fixed cost, which is like this, and this difference is my average fixed cost, right? ATC, AFC is nothing but ATC minus AVC. So this amount is this amount, this amount is this amount, and this amount is this amount. Yeah, so this is the difference, and this is my average fixed cost, and which is over here quantity and over here cost. And finally, the marginal cost curve or the marginal cost. Again, marginal is incremental, and which is changing, which is incrementing, that is the cost. Why cost changes? That is because of the quantity. Marginal product shows what changes? The product, total product, because of capital and labor. So when we discussed, or the marginal utility is changing because of number of commodities. Similarly, cost is changing because of number of production. So my marginal cost curve will be given as change in cost by change in quantity being produced. So it shows that how much cost additionally I have to incur if I produce one extra unit of output. How much cost I have to produce if I have to incur one extra output, and this C can be given as change in the number of, say, labor or whatever with the price multiplied by the price of labor. So it can be change in the price of X, which is the unit, or any factor which causing the change in cost, multiply the price of that particular factor divided by delta Q, and eventually we can call it Px 1 by delta Q by delta X. Can't we? So this delta X by delta Q is inverse delta Q by delta X, and this delta 1 by delta Q by delta X is nothing but 1 by marginal product of X. Change in output because of change in X, input X. So that is the marginal product in change in X. So MP had an inverted U shape, right? MP, marginal product, had an inverted U-shaped curve, if you remember. Yes, marginal cost have a U-shaped curve. This is my marginal cost curve. So if MP was like this, my marginal cost is like this. Yes, this is an U-shaped curve, just opposite. So this is my quantity and this is my cost for this marginal cost or production for the marginal product curve. So therefore, if I bring all this together, if I bring all these curves together, then I will have an average total cost curve. I will have average total cost curve I will have an average variable cost curve, I will have an average fixed cost curve, given my quantity and cost here. I just keep it, this is my MP. Yeah, and my marginal cost curve will be, my marginal cost curve, what color shall I take? I can take this orange one. The marginal cost curve should be something like this. This is my marginal cost curve, which will intersect the average variable cost and average total cost on its minimum points. Remember that, which will intersect. So the average total cost and average fixed cost come closer to each other because the average fixed cost is being slowly smaller and smaller and smaller, and this marginal cost curve will, when on its way to rise, it will cut or intersect the average variable cost and average total cost on its minimum point. Thank you.